Okay, so next topic that we are going to understand is all about the operations of linked list. This is what we are going to do it. When it comes to operations of linked list, we have different operations. We will see one after the other today. We will solve the problems. We will understand how it is working. That and all we will do it. So in the previous session, what we have understand is we created a empty linked list and we keep on inserting the node inside the front of the linked list, and then we traversal the entire linked list and we display that value. So this is for all to understand what exactly the code looks like and what is the structure of the code and how it works. This is what we have done in the last session. So today's session, it is all about operation of linked list, entire operation, all the operations we will be doing one after the other. So first operation, it is going to be insertion. Second operation is going to be deletion. Next operation is going to be searching and sorting and traversing. Okay, so these are the things that we have to discuss. The first, when we say about insertion in the beginning, so front of the linked list I can able to insert. So that is what in the previous session we have discussed. Now we need to understand insertion at any position. Insertion at any position, maybe fifth element or seventh element or second element or third element, something where in between the first and last node we are going to insert it. This is one. Next one, it is all about the last, which is deleting the node in the last of the linked list. Insertion in the node in the last of the linked list. This will happen for deletion also. This case will work for deletion also. When it comes to deletion, deleting the first node, deleting the last node, deleting at any position would be the one that we are going to consider. Okay, so that is what we will be doing. And when it comes to searching, it is all about linear searching. We will be keep on inserting one. We will have a set of elements inside the linked list, and then we are going to iterate each and every index position one after the other, and we will be finding the current of data values. That is what we will be doing. So we will see the program when we are implementing it. And sorting, I'm going to use bubble sort technique. So we have a lot of sorting technique: insertion sort, bubble sort, selection sort, merge sort, quick sort, and all is there. So we will be learning all these things. So here bubble sort is the one that I'm going to use it in order to explain the sorting technique with the time complexity of n square. For your understanding, I'm going to make it with brute force method. Then later you can improvise the code and you can able to implement it. And then last one, it is all about traversal, which is displaying the data, of each and every node and executing one after the other. So traversal is all about visiting each and every node and displaying the data part of that node. This is already done, and this particular module is already done. So next module that I need to complete is going to be last, then we will go to delete. So today this is the first topic we will be completing. This is the second topic we will be completing in the insertion operation. Simultaneously we will be doing for deletion, front, last at any position is the one that we are going to do it. So let's get started. First, let me explain you the diagram of insertion at last. Okay, so going to this particular position, taking a new node that I'm going to insert it. Okay, all right, so let me take this particular node, copy this and put it here. Okay, so this alone let us take. Okay, so we have created a new node and it is what we are going to do it. So now we will start the operation first, and then we will keep on executing one after the other. So let me decrease the size a bit so that it will be for you, it will be easy to view it. Okay, so inside the class we have an insertion operation in the front. This is what I was explaining in the last session. I preferably wanted you people to use Visual Studio Code. For me, I have some technical issues, so I couldn't able to use Visual Studio Code. So make sure that you follow the Visual Studio Code, the installation procedure and all. We would have been helped you in the Java course or in Python course. Okay, so now moving to the next one, it is all about inserting the node in the last. Okay, so insert in last. So this is the operation that I'm going to do it. So inside this. Okay, so now what I'm going to do is, first of all, since it is an insertion in the last, okay, I'm going to insert this node in the last of the linked list. I need to create this node. So in order to create this node, I'm going to give 5. Address of that is going to be 500, and the name of this new node is going to be new node, and the next part of the new node is going to be null. Okay, so now what I'm going to do is I'm going to create the node. Okay, so let us create the node first. Okay, so let me get this code. I'll put it here. Okay, so node is being created. Now I need to check whether head is equal to null or not. Why? If head is equal to null, okay, if head is equal to null, head is equal to new node, I need to specify, which is, if I am going to take this node where head is equal to null, consider head is equal to null. If it is going to be null, I'll be having new node inside the linked list. The first node and the last node, it will be same, right? If I'm going to insert it, the first node and the last node, it is going to be same. So what I'll be doing it, I'll be taking this address, okay, and I'll be storing it this particular index position, and I'll be connecting to this one. So by this I can say the node is being connected. This node is being connected, which is I am getting the address of 500, address of the new node, which is 500, and I'm storing inside the header part. So this is what ultimately we are doing, one after the other. Is that understood? So what I'll be doing is, if my head is equal to null, and when head is equal to null, then head is equal to new node. Then moving to the else part. Okay, so what if this particular condition gets failed? So go to this one, go to this piece of code. Okay, let us take this one, this particular linked list, head is equal to not equal to null. Okay, so in the previous condition, head is equal to null, I have made that condition true, then it was working. If that condition was not working, then this would be the case that you will be having it. So what you need to do is, you need to insert the node in the last of the linked list. That is what we were doing. So here also we were doing in the last, right? We were doing this particular node in the last, right? In the same way, here also we are going to insert the node in the last of the linked list. So we need to establish the connection between these two nodes. So for that, what I'll be doing is, I'll be making first node as a current node. Which node I'm going to make it as current node? The current node is nothing but your head, which is the 100. Head 100 is given, no? So that is what we are going to implement it. So first, making head node as a current node. So let me write that statement. So what I can do is, where node current, okay, node current is equal to head. Okay, this is the first line that I need to do. Then I need to iterate this node each and every index position. So if I need to iterate each and every index position, current next part will be equal to current. So which is, what I'm going to do is, in this one, current is equal to current dot next. So what is current dot next? It is going to be 200, right? In the place of current dot next, I am going to mention 200. Listen here, what I am doing, 200, right? If I mention 200 here, what happens? Automatically my current becomes 200, right? My 200 becomes current. So my pointer moves to the next position. So this keeps on moving to the next position. Okay, so you'll be moving from here to here. So which means your current will be moving here. Then current next is not equal to null. Yes, it is not equal to null. Then I make my current dot next will be 300. So here 300 will be given, right? Then what happens? My current will be moving to the next index position. right? My current will go to this particular index position. Is that clear? Right. Similarly, you will be moving this one here, making my current is equal to 400. My current will be equal to 400. My pointer automatically comes to this particular position. Now current is the last node of the linked list. Now we need to establish the connection between these two. So what I need to do is, since this node is a current node, what I need to do is, so first we will iterate. We keep on iterating one after the other. No, that we need to write as a code. So what I'm going to do is, while, since I am repeating the step, I'm going to make current not equal to null. So when current is not equal to null, then current is equal to current dot next. Okay, so by this I would have iterated to the last position of the linked list. Now what I'm going to do is, I need to connect my current and the last node, which is the new node which I'm going to insert. So I need to establish the connection. So getting the address of the new node, and I'm going to store it inside the current node next part. Okay, so getting the address of the new node and I'm storing inside current node next part. Okay, so that is what I have done. So which mean current next part, what I have done, current dot next part, I have stored a value called 500, which is the new node address. Now instead of 500, I'm going to write new node. So by this I can say the current dot next is equal to new node. Okay, the current dot next is equal to new node. So let us establish the connection between these two. Okay, so I have established the connection, and now this is how the diagram looks like. So current dot next is equal to new node. The same line I'm going to write it here. So current dot next will be equal to new node. Is that understood how we have performed? Okay, so since we have completed the program, we have completed the operation of the insertion on the node in the last, so we are going to call that particular function. Okay, so in the previous diagram I have already told you 40 30 21, because insertion in the beginning is happening. 40 30 21 would be the resultant linked list. So if I run the code, I'll show you. This is how. Okay, node current line number 41, just line number 41, current is equal to, okay, so let us run the code. We will understand how the linked list looking like, which is 30 40 10. So insertion in the last node, I'm going to insert a value called 50, and I'm going to insert in the last most position so of the linked list. So what I'm going to do is, after this one, L list is the list that I've created as an object in the name of linked list in the for the class called linked list. So insertion in the last is one that I'm going to do it. So inside that I'm going to give 50, right? So let us run the code and we will see the last node which is going to be inserted. Cannot able to assign the field, next is null. Okay, just a minute. Current dot next. Okay, so I made this last node which is going to be inserted, which is going to be 50 after the last node next part. So that by that I can say this is all about insertion in the last. Okay, insertion in the last. This is how insertion in the last will work. Okay, then moving to the next one, insertion at any position. This is what we need to do it now. So insertion at any position we will see in the diagram, then we will jump into the code. Okay, so next one is insertion at any point. This is what we are going to do. The middle diagram, what I have explained, is all about insertion in the middle. Okay, so copy this. Okay, so let me place it here. I can increase the size a bit. Okay, so now what I am going to do is I am making the first node as a temp node, and I'm going to iterate to the nth position. After that nth position, we are going to insert the node. So here 1 2 3 4 is given. So on the third index position, I'm going to insert 5. So 1 2 3 4. Okay, so insertion in the last 1 2 3 4. Okay, so 4 element is needed to be inserted. No, so wait. Last according to the diagram I'll do it. So remove this particular line. Okay, so which is 1 2 3 4. No, okay, just run the code and check it how this node is looking like. So 1 2 3 4 are the node which is present inside the linked list, one after the other. So in between 2 and 3, I'm going to insert a value called 5. This is what I am going to do it. So which means what I am doing is list, okay, dot insert at any. Okay, inside the bracket I'm going to give two variables. One is nothing but the position, so which is on the third position I'm going to insert my value 5. Okay, so on the third position I'm going to insert the value 5, which is in between 2 and 3 I'm going to have my 5. This is what I'm ultimately going to do it with this particular piece of code. So now I need to have insertion any, right? So go to the process. Here I'm going to create a new method. So void insertion at any. So here two variable is going to be declared. One is going to be position, another one is going to be int data, because new node I need to create now. So int data. So inside this I am going to create the new node. So node new node is equal to new node of data. Node of data, I'm going to insert a value called 5, so which is data. Is that clear? So that is what we are going to do it. So semicolon. After this I need to check if the if you are going to create, see, consider that this particular node it is going to be null. Head is equal to null. Okay, so if head is equal to null, directly I'll be connecting to this node. No, same statement what we have done in the previous thing, like this we need to insert it. So what I'll be doing, I'll be creating the new node which has 5, and I'm going to insert this particular new node inside the head. This is what we need to do it. So that piece of code we have already done before, so I'll be doing it. If head will be equal to null, head is equal to new node. Okay, that's all. So in the else part, what I need to do is, this is where actual execution happens. Now what I am going to do is, inside this part I need to iterate till limited position. I need not to iterate till the last, because in the previous code what we have done is we keep on iterating the node until it gets null. So once it becomes null, it will stop the loop, but here it is not so. So based on the position we need to do it. So for that, what I'm going to do, first we can make okay, 1 minute. Okay, first we can make first node as a temp node. So this is what I made, first node as a temp node. If I need to make first node as a temp node, what I can do is node temp is equal to head. Okay, this is the first thing I'm doing. So node temp, so this one will be equal to head. This is what I have done. Is that clear? So once I made this one, I need to iterate this loop for multiple times. How many times I need to iterate? I need to iterate only one time, because I'm there in the second position, right? Already we are there in the first position. Since we are already there in the first position, I am going to have the index position is going to be 1, right? Index position is going to be 1. Okay, so for that, what I am going to do is, so for for I will be equal to 1. Since I am starting from the first position itself, I will be equal to 1. When you are initializing, I is equal to 1, condition is going to be true. I is going to be less than or less than position. Okay, less than position. So I plus plus. So by this I can able to iterate for the limited number of time. So now what I'm going to do is, since I had made my head is equal to temp, I should keep temp to the nth position, right? So temp is equal to temp dot next. Temp is equal to temp dot next. Whatever we have done, current is equal to current dot next, it is the same line I'm going to do, but here the variable name is different. Temp is equal to temp dot next. So what I'm going to do is temp dot next. What is temp dot next? Listen here, temp is equal to temp dot next. Okay, this is what we have done. Temp is equal to temp dot next. So now what I'm going to do, temp dot next is what? 200, right? That 200 in the place of temp dot next, I am going to give 200. So what is 200? 200 is nothing but the next node, no? So that is how this made as a temp. Second node is made as a temp node. Second node is going to be made as a temp node. Now I made that node, first node to the second node, it is going to be 10. The condition gets one time true, and when it gets incremented to the next position, it will become false. So here what I am going to do is, third position I'm going to insert, which is I have to give till 2. Right, so third position I need to do till that it has to work only one time, it has to work. So what I'll be doing, -1 would be the position that I'm going to consider. Is that clear? Okay, so now I have reached to this position. Okay, my pointer is being reached to this position, my temp is reached to this position. I need to connect these two nodes between I need to connect this node between these two nodes, right? That is what we are going to do it. So here what I'm going to do is, it is all about very simple concept. Disconnect this establishment, and I am going to remove this one, and I'm going to connect here. Okay, so I have established the connection between these two. Okay, alright, just listen. Okay, the connection is being established. Now what you need to do is, I need to connect this node, temp node, with the new node with the next temp dot next node, which is temp dot next is what? 300, no? So that 300 is this node called 3. So you need to connect these 3 nodes connectively. Okay, so one after the other. So what I am going to do is, first let me connect this new node to the temp dot next node. What is temp dot next? Temp dot next is 300. 300 is this one. This 300 I am going to store it inside the new node next part. So every time when you have this one here, it will be null. But here, if it is going to be null, then I need to connect these two things. So for that, what I'll be doing, I'll be establishing the connection between these two. Okay, so now I have established, which is new node next part, I got temp dot next. So temp dot next I am storing inside new node dot next. So what I can do is, new node dot next will be equal to new node dot next will be getting what? 300, no? So will be equal to 300. So what is 300? 300 is what? Temp dot next, no? Temp dot next is 300, no? So that is what we are going to do it. So is equal to temp dot next. Okay, will be new node dot next is equal to temp dot next. So temp dot next, I need to connect these two nodes, which is temp dot next should be connected with a new node. So these two. So getting this 500, and I'm going to store it here. Delete this and store it here. So which means I'm going to link this connection here. Okay, so this is what I have done. So temp dot next, sorry, temp address, I am sorry, new node address I'm storing inside the temp dot next. So temp dot next will be equal to what address? 500. No, what is 500 name? New node. Very simple. So new node, that we can able to do it. Is that clear? Is that clear? So let me execute this code and we will see how this is running. I need to insert in the third position of the given linked list. 5 has to be inserted. If you run the code, it should work. Let's see what has happened. I have missed a semicolon somewhere here. Okay, run the code. Okay, index position I didn't declare, I value I didn't declare. Okay, let me declare it. Run this code. All right, see here, good, you know. So in the third position I've inserted a value called 5. So this is this would be the insertion of a linked list that we would have done. So we have completed 3 operations, which is insertion in the front, insertion in the at any position, and insertion in the last. So insertion operation is completely done, and we have done with traversal also. So this operation is completed, this operation is completed. So this operation is completely done, and this operation is completely done. So now we have to go with deletion operation. Okay, we have to go with deletion operation. So now we are going to this is the next hookup. So we need to delete one node from the front, one node from the last, one node from any position of the linked list. This is what ultimately we will do it. We will do that in the next video. Is that clear? Thank you so much, guys. Bye bye.